3.1 talks about quadratic functions and models. Quadratics will arise in a lot more places than we would like, so we really want to get them out of the way. We dedicated a section to them, and we pretty much discussed everything there is about them. So a quadratic equation is an equation of the form f of x equal ax squared plus bx plus c, in which a cannot equal 0. And of course, other than that, a, b, and c could be any real numbers. We know how to graph this. This is the graph of a parabola shifted 2 units to the left, 1 unit up. If it says sketch, do not label points. That's a rough sketch. You want to be really picky and pick the 3 points by all means. You don't have to do that unless the problem says label -2, a point below it and a point above it. -2 in there will give us a 1, -3 in there will give us a 2, and -1 in there will give us a 2. So if you want to be really picky, again, I'm not picky, but if you want to be picky, -2, 1, -3, 1, 2, and -1, 1, 2, good for you. You could be as picky as you like. You could not be picky. If the problem says sketch a graph and label 3 points, then you must label those. But if it says sketch a graph, which is the majority of the time, a quick sketch will do. Now, I do want to point out a couple of things. I do want to point out, if you take this and you FOIL it, then f of x would be x squared plus 4x plus 5. Now notice that the graph of x plus 2 quantity squared plus 1 is right there, and the graph of x squared 4x plus 5 is right there. I know this graph crosses the y-axis at 5 if I really want to be that picky. The deal is not how do you go from this is what we call standard form to the general form. The question is, how do you go backwards? So this is the general form of a quadratic. Given f of x equal x squared plus 4x plus 5, if I said sketch a graph of this, now you know how to graph it because you could see where it came from. But if you want it to complete the square, you could have x squared plus 4x so whatever number I add on the right, I must add on the left, or I could add it and subtract it on the same side. Take half of the middle number, if you remember, which is half of the middle number, which is 2, and square it, you get a 4. So f of x plus 4 equal, this becomes a perfect squared. And if you subtract the 4, of course you could have added and subtracted the 4 right there and got the 1. It doesn't really matter. And we take 5 minus 4, which is a 1. There it is. Now, I notice if I have the graph in this form, f of x equal, if I have the equation in this form, f of x equal a into x minus h squared plus k, the vertex is the opposite of this, and the y-shift is right there. And what if I told you, when we complete the square on a quadratic, we did that already. If I want to find the vertex, and the vertex is the most important point on a parabola, what if I told you the vertex is given by -b over 2a and the y value at that point? Meaning what? Well, if I want to find the vertex of this, I'll say the x coordinate of the vertex would be -b, remember ax squared plus bx plus c, remember again it's ax squared plus bx plus c, so b is, in this case, a 4 over 2 times, and a happened to be a 1 in this case, so the x coordinate of the vertex is -2. And once I figure that one out, I say, okay, well, I need to find y. Y would equal a -2 squared plus 4 times -2 excuse me, plus 5. Y would equal a 4 minus 8 plus 5. 9 minus 8 is a 1. So I know the vertex is at negative 2, 1. So I have 3 ways of figuring out the vertex. First method, well, if I was given the problem in standard form, no need to do any work. If I was given the problem in general form, either I complete the square and get the vertex, or I use negative b over 2a and y evaluated that. So if I could go from this to this, I should be able to go back. The only thing that stays the same between the standard form and the quadratic general form is the a. So let's try that on the next few problems. Here's a direction. Now our book doesn't ask for certain things. I'm going to add them as we do this, just to make sure that we're all clear on that. A quadratic function is given. Find the vertex and express the function in standard form. Sketch the graph labeling the intercepts and axis of symmetry. State the domain and range. Well, alright. You'll notice anything that you need in a parabola is tied down to the vertex. We know this graph opens up. We know that. We just need to, and we know that since they said find the intercepts, well, if I let x equal 0, in any function, the x-intercept is the y-intercept is the easiest because there's only one of them. Now comes the tricky part. Well, what is the vertex? The vertex is plus or minus x, and I don't know what's going to go there. Well, how does that work? I could complete the square. I could use this new trick. I could say the vertex is negative b over 2a. So x equal negative 6, again negative b over 2a, 2 times 1. The x-coordinate of the vertex is negative 3. There it is. And if I plug that in, f of negative 3, that would be 9 minus 18 minus 2. That's a negative 9 minus 2. That's negative 11. So this is not a plus. This is a minus. So I know it says find the vertex. I'll set the vertex clear to be negative 3, negative 11. So negative 1, negative 2, negative 3, negative 1, negative 2, 3, 4, 5, 6. You know what? I'm going to go by 2. So I'm going to change that point. I'm going to say that point is right there, right? And I'm going to go negative 2, 4, 6, 8, 10. That's negative 12 right there. So negative 11 is about right here. And I can sketch a graph because I know it's going to go through the intercepts, and on the left it's going to mimic that. Now I found the y-intercept. The x-intercept is the most work. So find the vertex. We did set the vertex. Express it in standard notation. There it is in standard notation. Sketch a graph. We just did. Axis of symmetry. It's very easy. What line breaks this in half? That's x equal negative 3. So you see it's tied to the vertex. And if I say state domain and range, domain is all real numbers. We all know that because there's no radical, there's no fraction, there's no log. Range deals with the, again, vertex. Isn't that the lowest y value you could ever reach? And later on they say, what's the maximum or minimum value? Well, isn't that a minimum, the lowest point? But we'll talk about that when we get there. How do you find the x-intercept? A good practice. Find the x-intercept, you set y equal to 0. And that's the most work normally. That's why it's important to sketch a graph before. 0 equal x squared plus 6x minus 2. Or even better, I've already figured this part out. Instead of me completing the square or using quadratic formula, it's right there. I don't need to write this. I could use the standard form. Subtract 11 from both sides. And what do you notice? Square root both sides. and x would equal negative 3 plus or minus radical 11. So the way I write this, negative 3 plus or minus radical 11, 0, and 0, negative 2 are the intercepts. Again, that turns out to be the most work. Well, if you have it in standard form, you just save yourself a lot of work. How about this problem? Well, the same deal. I'm glancing at this problem and I'm thinking, okay, well, I know this is a parabola that opens down. So this parabola, the negative, indicates that this opens down. And the vertex, which is my first concern, is negative b. Let's do it way on the side. Negative 4 over 2 times a. The x-coordinate of the vertex is 2. Throw 2 in, I will get a negative 4 plus 8, which is 4. So, I have a vertex at 1, 2, 1, 1, 2, 3, and 4. Very good. Now, I could write f of x as negative x minus 2 squared plus 4. That will save me a lot of work if I need to. I know it opens down. The intercepts 0, 0. And if I set y equal to 0, I don't need this because this factors. So I know it is at 0, 0. I already listed that, and it's at 4, 0. There. This is as good of a graph as I'll ever get. This point is at 2, 4. So when they say, alright, what's the axis of symmetry? Axis of symmetry, x equal 2 is the axis of symmetry. If they don't ask for it on the homework, you don't have to do it. I'm just showing you what that is, because that does come up in other books. Alright, and what else is there? Domain, all real numbers, no big secret. Range, well, again, it's always the y value. Isn't that the highest you could ever reach? So wouldn't you say that is negative infinity to 4? There it is. Make sure I answered everything they wanted. We wanted graph, vertex, function, standard, sketch, intercept. Yep, everything's there. Very good. Alright, let's do another one. So again, not that bad at all, but it's very important because later on in this chapter we're going to get to quadratics every time we reduce a polynomial of higher order. Alright. Same deal here. Well, I know that this opens down. Okay, I have a good idea. So let's see how this works. Now, and I know it crosses at 0, negative 3. Do we all see that? 0 for x, that's gone, it's right there. The y-intercept in any function is the simplest point. Now, I want to figure out what the vertex is. The vertex, I'm going to take negative b over 2a, negative 6 over 2 times a is a negative 2. That's the x-coordinate. That is 3/2. So the vertex is at 3/2, and let's see, what does y equal? Y would be negative 2 times 3/2 squared is 9/4, plus 6 times 3/2 minus 3. Y would equal negative 9/2 plus 18/2 minus 3 over 1. So this is positive 9/2. Alright, negative 9/2. 9 minus 6 is 3. So 1, 2, 3, 4, 1, 2, 3, 4, 1.5 and 1.5. And we know this opens down. I could sketch a graph with what I have. this graph is symmetric. Alright. I see there are two x-intercepts. So I'm going to go ahead and figure out, write it in standard form. Y equal, so notice that's the only number that's matching x, the opposite of that. That's the standard equation of the parabola. I need to figure out those intercepts. So if I go for figure out what those are, again, this is the best form to use. If I say if I am to say set that equal to 0, 0 equal negative 2 into x minus 3 halves squared plus 3 halves. Well, negative 3 halves equal negative 2 into x minus 3 halves squared. The beauty of this, it's always a square. So I could always isolate the square, divide by negative 2 both sides, or multiply by negative 1 half. That will be 3/4 equal x minus 3 halves squared. Square root both sides. Don't forget when you square root, you always pick a plus or minus. And move that over, and x would be x would be 3 halves plus radical 3 over 2 and 3 halves minus radical 3 over 2. To the right the positive, to the left the negative, and that's pretty much it. The axis of symmetry, again, if you label this point as 3 halves, you can get everything from there. Axis of symmetry is x equal 3 halves, it's that value. Domain is all real numbers on all parabolas. Range, however, is going to be negative infinity to 3 halves. Alright, let me just see how many we have. I could do this in about 7 minutes probably. So yeah, one video will do. Okay, how about this problem? Same deal. If I take the vertex, that's negative b over 2 times a. Oh, I meant for that to be a plus. I'm sorry, my apologies. There we go. So for the vertex, I'm going to take negative b over 2 times a. That would be negative 3/4. Okay, now to figure out y, I'll say f of negative 3/4 is going to be 2 times 9 over 16 plus 3 times negative 3 over 4 plus 1. That's going to be 9 over 8 minus 9 over 4 plus 1 all over 4. 9 minus 2 times 18, 4 times, and that will be, what is that? Negative 9, negative 5/4. Negative 3/4, negative 5/4. So let's say that's negative 1. Negative 3/4 is about right there. And negative 1 and 1/4 is about right there. I know the graph crosses at 0, 1, so I can pretty much sketch a graph. That's the easy part. The vertex is at negative 3/4, negative 5/4. Well, we know the drill. The axis of symmetry is x equal negative 3/4. Domain all real numbers. Range negative 5/4 to infinity. Okay, and what else? Standard equation. f of x equal the 2 you carry over x plus 3/4. If you remember, that's always the opposite, minus 5/4. There's my first. And what else do I need? I need the vertex they set to label. It's right there. You could label it right there. And I want to know where this equals 0. That's the most work. Set this equal to 0. So if I have 2 into x plus 3/4 squared equal 5/4 multiplied by 1/2, square root both sides and move the 3/4 over, and there it is. Oh, this should have been over 8, right? Yeah. So I made a mistake right here. Oh boy. Forgive me. 9/2 multiplied by 2 multiplied by 8. That should be an 8 over. That changes everything. So that's what? -9 but -1/8. Okay, well. There it is. And if I make that, that becomes positive 1/8. Multiplied by 1/2, 1/16. Add, oh, this factors. I could have factored instead of doing this, right? I could have said this equal to 0. That is 2x plus 1 into x plus 1. That is, so x would be -1/2 or -1. Or I can finish this. Plus or minus 1/4, and if you take -1/4, 3/4 plus 1, that's -2 divided by 4, that's 1/2, and if you take -3 minus 1 is -4 divided by 4 is -1, but you list those. And that's all we need. So this is the most work that they could ask for. Generally speaking, they don't ask for all of these things. They say something like a quadratic, express that equation in standard position. You say, okay, well, what's the vertex? -b over 2a, that's -3, -b, I meant. And if you plug it in, f of -3 is 9 minus 18 plus 4. That is -9 plus -5. So they say standard form, f of x equal x plus 3 squared minus 5. Sketch a graph. 1, 2, 3, 1, 2, 3, 4, 5, and as a rough sketch will do. You don't have to be exact. There it is. And then if they say find the maximum or minimum value, well, look at this graph. Isn't that the lowest you could ever get to? So we have a minimum value of, and that's, what's the lowest value you could ever have? The answer is always in there, of -5. If they say, when does that happen? When x equals 3. And what if I'm looking at a problem like this? Well, the same deal. Vertex is the key. What's the vertex? Vertex is -b over 2 times a. That is a positive 3/2. And if I plug that in, -3 times 9/4 plus 9/2, no, plus 27/2. Right? 9 times 3/2, 27/2 plus 1. So that is all over 4, -27 plus 54 plus 4. That's 27, that's 31/4. So 3/2 is 1.5, let's say that's 1, 2. 1.5 is about right there. And 31/4, that's about, what is that? 7, 8? 7, 8, so somewhere in there. There. this parabola opens down, something like this. I could use the y-intercept because that's always easy to find if it's a parabola, to really sketch as accurate of a graph as I can with the least amount of work. Okay, well, isn't that the highest you could ever reach? Isn't that a maximum? The maximum value is, and what's that? It's always in the vertex, you guys. It's always the y value. And when do you reach it? At 1.5. Now we're going to look at one application problem really quick. And this is what it says. A small business analyzes their sale records and finds that if they sell X units in one day, their revenue, that's how much they could sell, in dollars is given by this equation. What is the maximum revenue per day, and how many units do they need to sell for the maximum revenue? Well, you're looking at this. There's the R revenue function. I see an upside down parabola. I see y equal negative 0.001 x squared plus 4x minus 1100. That's a parabola, an upside down parabola. It has a maximum. They didn't ask for a graph, but I know it's upside down and it's going to cross at negative 1100. Right? What's the vertex? Vertex, negative b over 2a. Negative b over 2 times a. So that's a positive. Divide it 2. 1, 2, 3, 1, 2, 3. That's 2000. And y equal negative 1 over 1000 times 2000 squared plus 4 times 4000 is 8000 minus 1100. 3 zeros cancel out. 4000 negative plus 7000. No, I'm sorry, not 7000. That's not 1000, that's 1100. Let's say plus 8000 plus 11 minus 1100. So altogether, what are we looking at? We're looking at 4000. 4000 minus 1100 is $2,900. So I could say y equal negative 0.001 into x minus 2000 plus 2900. If I was looking at this graph, 2000 and 2900, when it says what is their maximum revenue? Remember, y is their revenue. Maximum revenue is $2,900 per day. Right? And how many units do they need to sell when, how many units? 2,000 units are sold. There it is. And that's all there is about quadratic.